So I've lifted off the rear wheels of the car, and it's now connected. So let's see what happens if I turn on the motor. And here we go. You see the RPM, we see the distance traveled, and we can speed it up a little bit. Starting to vibrate a little bit. I'll slow it down again. So we have feedback. Cool. Let's see how we got here. So let's take a few steps back and how are we going to achieve that? One way to get feedback is using what we call a Hall sensor. Hall sensor is a sort of magnetic transistor, so it's a switch that switch on and off based on if it feels the presence of a magnetic field. There are different kinds. There are analog ones that will respond gradually on the strength and direction of a magnetic field, and this is a digital one, so that switches on when it sees a magnetic field and off otherwise. So that's pretty straightforward to work with. It's for all intents and purposes, you can use it as a push button. Every time you push it down, then it's on, and when you let go, it's up. So this is one from Amazon with a bit of a board attached to it, and it also has an LED attached to it, so that makes it easier to play with, because you don't need to wire it up to anything to measure the signal. So right here on my the tip of my screwdriver, I have a little magnet. So it's a pretty powerful small magnets, and if I hold it near to the sensor, it lights up if I'm like closer than a centimeter or something like that. And these are very common in these kind of situations because they don't touch, so there are no moving parts, they don't wear down. Depending on which hardware you use to read it, it can respond ridiculously fast, so you can also use it for fast, for very high frequencies. So one of these, let's see, this is one I'm using on the board. It is technically cheaper just to buy the components, they're much cheaper, but this is also not going to break the bank. And right now I'll incorporate those in my car. And I've wired them up, so there are 3 wires there. You can see on the left side. I can point to it like here. This one is the minus because it's rotated. The middle one is plus, and the right one is signal. That will be high or low, depending on whether there's a magnetic field or not. So I have to wire that up in the car. I have to connect this thing somewhere in the car, and then I'll need to connect a magnet to the wheel, and then every time it passes it will give a pulse, and then I know how fast this wheel is spinning. Probably would be better to put more magnets in the wheel, at least like 2 or something like that, so it's balanced. Right now I guess it will shake a little bit, but it doesn't really matter to us. So let me rewire a little bit and show what it looks like when I connect it to a car. So here we are. I extended the mount of the bearing a little bit, and on the side there I put the sensor. I bent it down a little bit so it's pointing roughly to the right spot. I removed the wheel, obviously. And the wheel is right here. So in the end I went for the simple solution. I just used a hobby knife to cut in like a little square, jammed the magnet there. You have to take care though to get it in the right direction, because it has like 2 poles, and it's specifically sensitive to a certain direction. So you need to at least check that. And I jammed it in. There are way fancier ways to do that. You can find places for that, but let me check. No, like here. This is the print of a wheel, and what you can do, which I really recommend, but this kind of worked fine, so I never really bothered. But you can just print an object and insert a pause in the middle, and then so you basically include a cavity in your 3D design. You create a cavity and you can pause the print, and it can then, as it is printing, I don't know what's happening here, then you can basically, as it is printing, insert a pause so it will stop and it will remove your print head for a moment. You can push in the magnet and then it continues printing, and then it's just inside the wheel. You can't see it, can't fall out. So that's kind of nice, but I ended up not doing that. So having this out of the way, this one I wired to pin 9 or 10, I need to check. And from then on, let's look at the software, because that's why we're here, right? So I'll meet you back here in a moment. So we're back in the code. I didn't change much since the last time. I only update some dependencies. There were some major releases, like Embedded Hell had the final 1.0 release. But for the rest, it's pretty much where we left off. In true Rust fashion, let's start with adding a type, or at least a type alias at first. Let's make a alias for the pin we're using. Let's call it tag pin for tachometer, and that was GPIO 10. Actually, I had some issues with, I tried on 19 or 18 or something, and that didn't seem to work right. I don't know why, but this one seems to work, so one day I'll figure it out. Input, I think it has an internal, the sensor has a pull down resistor, so I think we can just do floating, and that should do it here. Second thing to do would be to go to the protocol. The protocol, so this is the things we can communicate, and we had the telemetry message, so that's a message from the car to the controller. And let's add something there, and let's call it motor RPM, and let's put the U64, and also a motor odo from odometer. So because we want to measure two things, like how fast it's running and how much it ran in total. So two different commands. So that's the kind of the infrastructure in place. But if we need to think about how exactly do we want to send that, because what we're gonna get as the wheel rotates, you get a series of pulses. We want to know how fast they are running, and we want to get a total and send them both. But we don't really want to send every single pulse as a message over the ESP now to the controller, because that will kind of drown out all the traffic, and it's not necessary. So we need to do two things. We need to catch the pulses as they happen. That's one thing. And then periodically, every second, maybe less, I don't know, we need to send an update to the controller of what the status is now. So let's start by adding a task. I think here we're going to do mostly pretty much everything on the side of the car, not so much the controller. Let's create a new file. So let's call it tag for tachometer RS. We add it in the main. And we need to instantiate a task that will do those different things. So they all have their own timeline, right? Two things. So it's catching the pulses, and the second thing is catching and sending those pulses periodically to the controller. But they are not really the same. They don't run in the same timeline. Did that work? Oh, I called it tech. Happy now? Excellent. So, what I'm gonna do, I'm gonna start to make a function, async of course, and I call it as well tag, why not? And I'm gonna pass the spawner into it, because then I can just spawn this thing from the central task, and then I can do all the two subtasks I can do from here, because that way you don't have to put the logic that you have to remember to put both tasks in the central one. So that makes this more of a reusable component. So let's add a spawner. And also what we're gonna need is the publisher. And I forgot function. It's classic. Let's see, this needs to be imported. And also I want to use the publisher, which I use to publish our messages, and that gets by the sender task will be sent over the airwaves to the controller. So we call it the publisher, and that's a message publisher. It's one of our own type I aliases. And another thing we need is a clock. Because we need to measure the time between the pulses to get any kind of meaningful RPM. So we add a real-time clock. We have used it before, I'm not sure for what, but there were reasons. RTC. I think that needed some annotations, I suppose. Yeah. So it needs static lifetime, and I think I also need to do a static borrow here, because yeah, we're using it for other stuff as well. So these are the ingredients. Let's start by making a task that is just fires that detects the changes as they happen. So let's call this function revolution. Every time a revolution of the wheel happens, this thing fires. So what does this need? First of all, it needs the pin. So tag this one. Name, and I just need to take ownership of that, so I don't need to borrow. Let's start here. So we have this pin, and we created a floating input pin, so that's all good. And what we can do then, of course, like always, we do a loop, and that pin we can do wait for rising edge or falling. It doesn't really matter. So rising edge, I suppose, then it will fire when the magnet approaches, and falling edge would be when it leaves again. Doesn't matter. It happens once a revolution. So we don't really care about the exact value of it. You just need to know that it happened. We need to make it async, of course, and we need to add for both. We need to add the task. Yeah, that one, annotation. This one too. So we wait for the thing. What's wrong? It's not mutable. And we need to do some things. We need to, if we want to do odometer, didn't need to unwrap, I suppose, yeah. So if we want to make an odometer, we need to remember where we were. So let's start by just creating a counter. Let mute odo is 0, U64. So every time this happened, we do odo plus this 1. So it will count. What's next? Next, we want to know how long it was between the last time there was a pulse, right? So let's create a variable. Let's call it a mutual variable last pulse, and let's initialize it to we didn't pass in the RTC, we need that one, so I'm just copying it because you're gonna need it here. RTC dot get time microseconds. So that gives the number of microseconds that elapsed since the board powered up. So that's fine for this, right? We don't really care if it's the real time or not, as long as it's some kind of time difference we're going to measure. So what we're going to do here is that whenever that pulse actually happened, we are going to record it. So let's first put it in a variable. We call it now, and we do the same thing again. Get time microseconds. So now every time, and at some point, what we're going to do, we're going to do some stuff, and then we're going to do last pulse is now. So right here, the value of the difference between now and the last pulse is how much time elapsed between the pulses. So if we would calculate, it would be something like elapsed equals now minus last pulse. So that's how many microseconds elapsed. If we want to calculate RPM, then we need to make a division. So let RPM, we are microseconds, so that's 1 million microseconds per second, and 60 seconds in a minute, because we want to do per minute. So that's 60 million divided by elapsed. And that should be the RPM, that's a U64 again. That's fine. Now what are we going to do with this thing, right? Because this function is never going to terminate. It's going to loop forever, so it's even nicer, I think, to indicate that here, to say that it's never going to terminate. We need to make a communicate that somewhere, because yeah, this is just one loop. So let's use a signal for that, and a signal is also one of the primitives of Embassy to send data from one task to the other. It's similar to a channel. So in the channel you can set values, and the receiving party has to receive them. There is a little bit of space where you can say a certain number of messages can be in flight. So maybe, I think in our case it's 10 or 50, I don't know. But at some point it will block, because if it's full. But you can also use a pub sub, so then you can send it to many. And that has also the property that you might miss messages, because it will never block. You can always send messages, and if you're quick enough you'll get all of them, and if not, you miss messages. And there's a special one, that's an even simpler one, it's called a signal, and you can always send to it, you can always send new messages, and you will always keep the last one. So every time there's a new message, it will overwrite the old one, and you use that to just get the latest. And that's something you want on a dashboard, right? You don't need to queue values up. You just want what's it like now. And for the auto, it also works because it counts here, right? You don't need to catch every pulse. Okay, let's continue. We are going to want to publish this data over our network. So let's make another task, and then I'll get into sharing that, how to share that data. Async function, we call it tag publisher. And what do we need there? Well, we need the publisher, message publisher, and that's gonna, again, let's say that never finishes because it's gonna loop. And then we can, we need to communicate between these two tasks. So this will do like a timer after melee, so await. I guess I need to import that. Await. So this will do something twice a second, every half second, and it wants to know what's going on, right? What's the latest auto? What's the latest RPM? So let's create some signals. Let's start here, because here what we're gonna do in this function, we're gonna link those two together. So let's create a signal for the auto, for example, and that's signal new, and then we need to import that, and that needs some type information, signal, and I think the first one is the mutex, which we don't actually need a real mutex because it's a single core, I think, and the U4064, because that's the value we're communicating. So what we can do, we can kind of split this thing in two, in a sort of sending part and receiving part. We pass it on to the tasks, and then yeah, they should be able to signal. All right. Let's create another one straight away for the RPM, because they have the same data type. And then, because we have the spawner here, we can spawn spawner.spawn revolution with tag pin. Oh, we didn't add that in this signature here. We need to figure that out as well. Here, I think. No. We have the pin, and we have the clock, and then we need to wrap, I suppose. And we need to add those signals. So let's do that. Add a signal, and that's of the type signal. No, wrong mutex and U64. And we add, we need of course both. One moment. Oh man, the screen is a bit full at this font size, but auto signal. And we do another signal for the other one, the RPM signal. Yeah, I think so. So we add here the auto signal and the RPM signal. Done. And then in this case, what we need to do, we have the RPM, we have the odometer, so we say auto signal, and then we call signal, so that will kind of send the message of auto, and we say RPM signal RPM. So this will never block, and because and we really don't want it to, because if this loop somehow runs too slowly, it's gonna miss pulses, right? So it is important that this thing is as tight as possible. Next up, let's take these two parameters and add them to the this side as well, even though I think we're gonna get into some ownership problems, but let's see. And we need to call this add this task as well, so we can do something. But let's start playing around in this function first. So this is we have those two signals, right? So we need to read them inside the loop, of course, and we can do like auto signal, and you can do a wait that will say it will wait until there is a value, but that's maybe not what we want, because if there is 0 is also a value in a sense. So I can just read the signal. Now what I can do is I can check if there is a signal, because I don't really want to wait for one of the two. So what I can do, that I just make an if, and then I do auto signal dot wait, and that will always terminate immediately, because yeah, I just checked that there is something, and I need to await it. And signaled assign it something somewhere, so let auto, and that's, I think I still need to unwrap. No, I don't. So I have a value now, and then I can just send it through our publisher. So publisher dot publish, that's a message, so message telemetry message, correct, and that's the telemetry message. Oh boy, there was odometer. So this the type, the enum variant we just made, and then we need to pass in here the value, and then I guess we need to wait. Don't unwrap, I think. Unwrap? No. So like that. So now we check if there's auto signal, and after the first iteration, first revolution of a wheel, there's always something. And then we await signal, which should be instant because we checked, and then we publish the thing. For RPM, we're gonna do the same. So we're gonna check the RPM signal, and RPM signal wait, call it RPM, motor RPM, RPM. So now, after, when they both got a value, both should be sending twice a second an update through the publisher, and the sender will send that back to the controller. But we're not going to really do that today. I'll just read it from the car's point of view. But we're not quite done yet here, because we need to spawn the tag publisher as well. The publisher odometer, and we need to unwrap it. And yeah, that is true. So let's make them into static mutable references, because that's what we need to pass it into a task. What's wrong here? I did this all wrong. I don't think we need that at all. Am I wrong? No, that makes no sense. Okay, we need to change the signatures, of course, a little bit, but now we can just share them. So that's going to be a static mutable signal, and this is going to be a static mutable signal. So that's correct, and the same here. Okay. I don't think I should make them mutable. Now the signal itself aren't mutable, I think. That was wrong. I think. Yeah. That worked, so this one should work as well. Okay. This one does not need to be mutable. Okay, if you say so. Yeah. Getting there, I think. So the only thing we need to do now is in our main function to call this whole thing, right? So we have yeah, we have to add this thing, and we need to do something else, and that's enable the interrupts, because we did that already before on the controller side, because we need to respond to buttons and so on. So let's this one was already there. We have a pin here. We create a floating input, so that's the pin we had in mind, and we need to do we need to enable interrupt. So that's enable, something like that. An interrupt, that's peripherals dot GPIO, and the level, I'm honestly not 100% sure what's best here. I put it on priority 1, and that seems to work, but yeah, I'm not 100% on what's this is different. think it's a whole different type. No, not that one. Yeah, it's this variant. I've never seen that before. Or is this the wrong one? Is the re-export maybe? Let's check. Yeah, that does something. Okay, and unwrap it. So now, otherwise it will get silently ignored, and that I found out the hard way can be tricky. But we have been here before, so this shouldn't be new. Then in our main function, what we're gonna need to add is to spawn that task. So spawn and unwrap already, just to get it out of the way. And then I forgot what we called it. Tag. Okay. So spawner we need to make a new publisher for this one. So that's again the command channel dot publisher. The tag pin already made, and I think did we maybe because they're the same name, just let's qualify it. And we need to unwrap it. Is this one correct? Yeah, I think so. Okay. So I think we've done a bunch of things. I think so. Now it would be hard to tell if anything happened at all. So let's add a simple task to just print out what's happening and if we are actually moving, right? So let's create a new function, and that will take a message subscriber. We call it I don't know, monitor RPM, something like that. Same thing. We're gonna loop. We're gonna just collect values, I suppose. So let's create two mutable variables. Last photo and last RPM, and let's listen to the subscribe, right? So message is it's called publisher, makes no sense. Subscriber dot next message pure, so that we'll wait for that. Is that the message? No, we need to wait it, of course. And now it's a message. Yes. And this should be mutable, I suppose. Yeah. So we have a message. Let's create a match for the message. And we can try all the variants. So we have control over telemetry. We're not interested in control at all. So let's just put a default one. And we call this telemetry. And with this one, so we have some kind of telemetry message. And we're going to match on that. Clippy doesn't really like that I do that I nest match statements. I still like it a little bit more than Dave's, but yeah. Here we get a whole bunch. So two of them we're interested in, the RPM and the odometer. I'll put them up here. And the rest we don't. So let's just put them all under the default branch. And for these, do RPM, give them a name, odometer, give them a name, and from here we're just going to save them in our mutable variables. So last RPM is RPM, and in this one we're going to do the same thing. Last odometer is odometer, and at the end of this, where's the end of the loop? So out of the match. So let's print something. Let's do a simple print that we just overprint the same line. So we end up overwriting the same line. So we get kind of a static line that shows that over and over again. So let's just print it out. RPM like this, and odometer like this, and then we do a backslash R, so that's a carriage return but not a new line, so it will rewrite the same line over and over again. Last RPM and last odometer. To make this loop nicer, let's add some formatting here. So let's add some commands here. Space greater than 4. That means that we're gonna align it. That's the greater than pointing to the right. We're gonna align it to 4 characters, and we pre-fill it with the spaces. So otherwise the text jiggles around all the time if it goes from 1 to 2 digits or something like that. And this is the same. So now we have this thing, monitor RPM with a subscriber. So let's add it to the tasks here. Oh. Spawn. Monitor RPM with a subscriber. So let's give it one and unwrap. And what else does it need? I need to unwrap that. Yeah. What's wrong here? Or did I? No, that's correct. I gave it a subscriber. What's the problem? This one, wrap and semicolon, right? Yeah, just weird macro stuff. The language server doesn't always understand. Okay, so let's see what this does. It's still connected, so let's see where we are. Let's add camera here. So this is where I remove the wheel, right? So it's uploading now. I will need to recharge the battery though to really show off it moving, or at least like turning properly. But let's see what happens first. So you already see there is some data. So it says 0. Let's see if I take just the magnet of the wheel and pass it over it, if that does anything. Yeah, I saw something. That sending message from car is annoying. But you do see that it works. So let's comment this one out for the moment. It's somewhere. Yeah, don't care. So let's do that. So without the battery, the wheels can kind of turn, but it will try to power the brushless motor over the USB port, and that doesn't always end well. But sometimes it turns a little bit. I did hear that the engine motor controller started up, so that's something. So let's go through its startup sequence. Clean up the terminal and then see if I move the magnet over it. Indeed. So let's install the wheel. Oops. I think I pressed a little bit too far. Something like that. And if I rotate it, where is the, yeah. If I rotate it, yeah, it's kind of hard to see. If I rotate the past the, you see the, no you don't see. You see the LED flash, and that will show some sort of RPM. It doesn't go down again, so that's something, unless there is some movement, right? Because the RPM will not show anything when there is no pulse. But that's something to improve maybe. I can try if I keep it off the ground. No, it doesn't really. What? Maybe? No, I need a battery. Let me pause and get a battery. One moment. So I hope it has some juice in it now. Let's see. It's a bit tiny battery though. So, added the battery. Turning on. Oh, yeah. The nut became undone, so the drivetrain fell out. So, well, on this I'm gonna call it. I'm gonna assemble it again. Next time I want to work on a dashboard that we can put on top of the controller, so we have a speedometer on the controller, because I think that would be cool. So, see you all next time, and thank you for listening to the end. Yeah, please leave a like. Again, I will do, I think, maybe 1 or 2 more on the RC car. Then I'm gonna do some more basic stuff again, because I think some people like that more. But we'll see. If you have ideas or things you want to talk about, let me know. Reach out on comments or LinkedIn, something like that. So, take care.